Hi, everyone. Thank you so much for attending another one of our NL seminar series at ISI. Today, we have an interesting talk on the Data Provenance Initiative. We have two speakers actually today, an interesting hybrid setup with Anthony Chen from Google DeepMind, who works on research on factuality and long context modeling. He received his PhD from UC Irvine last year. And we have Shayne Longpre on Zoom, who is a PhD candidate at MIT, and he works on data-centric AI and language models and their societal impact. So without further ado, let's welcome Anthony.
Yeah, thanks for having us. The talk is on the Data Provenance Initiative. It's a large-scale audit of dataset licensing and attribution. I want to point out that this was work done with a lot of people. So even though only Shayne and I could be here, there were legal experts, people from nonprofits, from universities, all involved in this project and who made massive impacts and made this project possible. As was mentioned, I'm at DeepMind, but this was work done while at UC Irvine, and I want to point out that it's not associated with Google. And Shayne right now is a PhD student at the MIT Media Lab. And I also want to point out that in this talk, we discuss licensing and our interpretation of the licenses that are out there for different data sets and what they could mean for commercial versus non-commercial use. But this isn't legal advice. And so if you build large language models for commercial use, this is only our general recommendation. It's not legal advice. So a high-level agenda, we're going to talk about what the Data Provenance Initiative is and why we think this was the right time to do a large-scale audit of AI data sets out there. We'll talk about what we exactly did in the Data Provenance Initiative. And then we'll talk about the Explorer, which is a UI for exploring the data sets that we annotated, as well as seeing statistics, where the data came from, how much of the data is commercial versus non-commercial, et cetera. And then we'll dive into some analysis using the Explorer to show that there's been a growing divide between data sets that are available for commercial use versus non-commercial use, where the data sources comes from, and where we think the legal situation could go going forward. And then this is an ongoing project, so Shayne will discuss at the end how you can become involved in the Data Provenance Initiative if you're interested. So this is the high-level talk. And to get started, Shayne is the one that sort of led this project and conceived of this project initially, so he'll start off by talking about the what and why of the initiative.
Thanks, Anthony, and thank you so much for having us. I'll kick off with a really quick motivation. So a lot of the co-authors of this work, including Anthony, myself, and others, had done a lot of work prior in creating data sets, either for fine-tuning or for large collections for instruction fine-tuning or even RLHF. And in particular, a lot of us received three types of questions when we produced these data sets. From my own experience, we put out from Google a large collection of thousands of data sets that others had created called the Flan collection. And that was put out in late 2022. And we had three categories of questions. The first one is, which of these massive instruction tuning text data collection is relevant for application? So if you're a startup or organization, or you have some niche application, which subsets are right for our tasks, our topics, the domains, and the languages that we're covering? And then another question, the second most popular, is related to which of the data sets might satisfy our ethical or PR concerns? And so who created the different data sets? What's the representation in them? And then the most common question is the number two here, which is, well, what data sets are legally permissible for us to use if we plan to commercialize or even not commercialize, but plan to do certain things? So what are the licenses, the terms? What sources did the data come from? And is there some precedence of use that others have used it before us? And all of these things we realized were lost when we compiled these large data set collections together, taking P3 supernatural instructions, various other fine-tuning data sets you might have heard of, as they are merged and combined, you lose a lot of the original information that's described in initial papers, that's attributed to the sources, that describes the intended uses. And so we end up with these big bundles of data that are intended for machine learning, but have all this information lost to them. And so when we asked this question, at least in my case, I said, let me go ask Google lawyers. I'll be back to you tomorrow. And then that sparked a large project because they had no idea, didn't really want to weigh in. Well, they had an idea, but they didn't want to give guidance for the whole community. And so we embarked on trying to provide some of this guidance or investigate this. So next slide. So forward one, if you're not convinced that this is a big problem, it's become a really big problem at the end of 2023. So if you look here, these are 3 headlines in December that sparked this. And the first one flew under the radar. OpenAI suspended ByteDance, which is the creator of TikTok, suspended their API access to OpenAI because they alleged that they were using GPT-4 to create synthetic data to train their rival model. And so this is them enforcing their terms of use that says if you're using GPT-4 in the loop to create or generate data that you train on, that's a violation, especially if you plan to commercialize. But the truth is many people are doing this. And so this is maybe the first high profile instance of a ban. The second motivation is that one of the most popular data sets for text to images, Lion 5B, with 5 billion images, was had some headlines around it showing that it had, up to hundreds, even thousands of images with very, very disturbing content in them. And while this was used to train many, many models, this came to light and caused, big issues. People were having to delete their models. It was removed from the data was removed from Hugging Face, I believe. And it just shows that some of those popular data sets out there have information that is legally and ethically sensitive that people just aren't even aware of. And the third headline, which everyone I think is most familiar with, is when the New York Times is now suing OpenAI and Microsoft over alleged copyright infringement by training on their work. So we want to show this is very sensitive and heating up in the AI community, but there are many concerns, quick forward one, aside from the 3 you see there, that matter when you're deciding what data to train on. And we've embarked on this project to try to systematically structure and encode this metadata in a way that's more accurate than Hugging Face or other platforms that currently exist. Over to you, Anthony.
Thanks. So, yeah, Shayne touched on a bunch of the issues with, licensing. And I think a natural question is, well, there's licenses on, let's say, GitHub or on Hugging Face. And so this is one of the first places we looked at. What are the licenses on Hugging Face associated with data sets? But as we dove deeper, we found that over 50% of the data sets have incorrect licenses. And this isn't, I wouldn't say this is Hugging Face's fault. Hugging Face is like a great repository, but it's just the nature of, collecting large data sets, putting them together. People that are creating data sets might not understand where their sources are coming from, and those sources might have licenses associated with them. When you're uploading a data set, it might not be the creator that uploaded that data set to Hugging Face. So anyone can upload a data set. And if I pick a data set and upload it, I probably won't check that it's the correct license if it wasn't my data set to begin with. And so this motivates the need to have a more in-depth analysis of licensing, provenance, et cetera, to get a sense of what's really in our data. And so to summarize the points that Shayne mentioned, we have a crisis now in data understanding, seeing what's in these big bundles of data. In provenance, seeing what data sources led to the creation of this data set and what were the characteristics of the source data. And transparency. So all these things combined together means that the big bundles of data that we use today are very opaque. And so the goal of this project is to shine some light onto what's in these big bundles. So we take a step back and think about how a data set is created. You start with some original source, like let's say Wikipedia. Let's say you're trying to build the initial squad data set. What you then do is you then use this original source, Wikipedia, Reddit, etc., and you build data sets off of it. And these days, you don't just create individual data sets. What you do is you take existing data sets maybe and bundle them into larger groups. So I remember back in the old day, there was small bundles like glue and super glue. And when those came out, I thought, wow, this is huge, 10 data sets. But now you have hundreds of data sets in a bundle. And so once you bundle them, you have these data collections. And if you're creating a data collection, you might release statistics like, all right, what are the languages in these data collections? Are they multilingual or are they English only? And then you might release information like, what's the task composition? Is it mostly QA, code? Is it a mixture of these two? Is it human generated or is it synthetic data generated by maybe, let's say, a large language model? But I would say that here is where the general metadata for these large collections ends. And our point in the Data Provenance Initiative is that we need a lot more than just task composition and languages to have a real understanding of what's in the data sets and what these data sets can be used for. So in the Data Provenance Initiative, we also collect who created these source data sets, as well as where the original sources come from. And then what are the licenses, not just of the data collection, but of the individual data sets and the original sources. And then we use that to make informed decision on what's commercially usable versus, let's say, academic only. We also record if the data sets are human annotated or, let's say, machine generated. Going beyond this, we use automatic methods like prompting to figure out what are the breakdown of the domains and topics within these data collections. So how much is it of it is like brainstorming and creative generation versus short generation like, factoid QA. And we also measure things like text metrics and things like time of collection, because there's been some papers that show that if you pre-train or fine-tune on data that's further away from the current time, the ending model will do worse. Citation counts to say how often these data sets are used, as well as links to aggregators like GitHub, Archive, and papers with code. And this is really useful because different places can have different reporting of the licenses used. And when we're trying to decide whether a data set is commercially usable or, let's say, academically usable, we sort of aggregate the information across these aggregators to make a decision. So zooming out, we group these into the screen section, which we call characteristics, things like topics, tasks, identifiers, which are links to other sites like GitHub, Hugging Face. And I will say that these two are very, these are based on machine analysis. So there's not a lot of human annotation going into this work. The place where there's a lot of human annotations is in this last category of provenance. So here what we're doing is we're finding licenses, trying to categorize them based on the type of use that's permitted, and then trying to resolve conflicts if different sources say that there are different licenses associated with the data set. So to dive into the license annotations framework, because this is where a lot of manpower went, I would say that most of the contributors that you saw on the first page were PhD students, master's students that volunteered to do this analysis, as well as lawyers. So the first thing we did for a specific data set is we went to all these sources and we tried to look for the licenses that was available for these sources. And these can be conflicting. So some might not have any sources. Some might say MIT. If you're reading a paper, it might not say the license associated with it. It might just say it's open source. And then GitHub might have two different licenses, a code license and a data license. So there's a lot to wade through here. Once we have all these, we try to pick the one that we thought best represented the license for that data set. And then we tried to bin them into three categories based on what you as a machine learning practitioner would be interested in. So the first is permitted use. Can you use it for all use cases, only academic use cases, or any use cases that are non-commercial? The second one is attribution. So if you use this data set to, let's say, create a model or to create a new data set, do you have to attribute it back to the source data set? And then this third category is share alike. So if you create a data set based on this data set, does it have to inherit the license of the original data set? And we thought that these three categories covered what a general machine learning practitioner would be interested in. So at a high level, what we try to address is that in transparency, there's a lot of undocumented data out there. And even if it's documented, can be really hard to audit where this data came from and what are the licenses associated with this data set, as well as copyright issues, train test split overlap. And without transparency, these things can all leak through to your resulting model. In addition, without fine-grained understanding of the data sets within a large collection, there are issues around understanding bias and toxicity, unintended model behavior. So, for example, if you don't know what the breakdown of task types there are in your collection, let's say code versus reading comprehension, then your resulting model might not behave as expected. And yeah, like I mentioned, all these issues lead to poor quality models. And then there's issues around provenance. So as I mentioned before, none of the sources that we looked at were good ground truths of the licenses. And many of them are either missing or incorrect. And the thing is also is to show sort of how opaque the current state is. There have been companies that have released models like Mosaic's NPT models with a license. And then afterwards, they've had to revise their license because new information has come out. And like Shayne mentioned, there's lawsuits around not understanding provenance correctly. Shayne, do you want to talk a little about this part?
Yeah, very quickly, there's been some really awesome work already in trying to document data, including data sheets and data cards and data statements, as well as the Data Nutrition Project and some higher level stuff like ecosystem graphs. So we want to point to these really cool works that are out there. But one thing that's been missing is one, adoption, but also encoding a lot of important provenance data in a way that is filterable and searchable, and actually going and doing the work. So we're trying to adopt this by going and actually filling in a lot of the values for these things and coming up with a structure that's legally guided to go and fill out the provenance and licensing that goes beyond what this prior work has done and allows it to be searchable on and more discoverable usable by practitioners in the longer run, we hope.
Cool. All right. So yeah, so as Shayne mentioned, there are a lot of good existing work out there, but we want to go a step beyond that and make this information searchable, extractable, and ultimately do some of this analysis ourselves. So what we did was, in our first version of DPI, we took 1,800 data sets. These are mainly alignment and instruction tuning data sets. And we did a large-scale dataset audit of these 1,800 plus data sets. And this includes the text metrics, text domains, licensing. So for provenance, what we did was for each data set, we tracked the data sets back to the creators and trying to find licenses. Using this collection of data sets, what we then did is we also broke down, let's say, how long were these individual data points for each of these data sets, what kind of languages were in these data sets, where did these data sets come from? And then finally, we made this easy to use. So we introduced this tool so that you can go to this data explorer tool, put in your characteristics that you're interested in. So let's say you're creating a model and you want to use it commercially, and you want to be multilingual. You can go to this tool and say, okay, I want, let's say, multilingual, commercially available, creative data sets. And the Explorer will filter down and give you a package of just this subset that you can use to train your models. So this is the collections that we covered. These include very popular data sets like Lion, ShareGPT. I won't go into all these data sets now, but if you're interested, they're in the paper. Here are some of the most popular ones that get thousands of downloads every month. So we try to cover a wide distribution of the different tasks that you might be interested in. So we have tool use, we have coding, we have human written data, and then we also have synthetic data like ShareGPT, which are just scrapes of ChatGPT conversations. And we did analysis of all the sub data sets within these large collections. All right. So before we jump into some of the analysis around like breakdown of licensing and where the data came from, I want to show the Explorer real quick. So I think Shayne can talk a little bit about the Data Explorer.
Yeah. So first off, at dataprovenance.org, you can go now. I apologize for my horrible front end skills, but we do have some really nice visualizations that some of our designer colleagues worked on that really break down what is in really the top 2,000 most popular instruction tuning data sets in 2023. And we're actively growing that, doubling its size with contributors from like double the amount of organizations we originally had contributing. And the goal of this tool is sort of threefold. We've seen three types of people use it. The first are model developers and startups and organizations training their own models that want to source compliant data for however that means to them. We don't tell them what they should do, but we give them the tools to decide and filter for what they want in their data, which could be a complex task over languages, as Anthony said, tasks, topics, original sources that they think, do you want the New York Times data in there? Do you want to be very conservative? Do you want, what licenses do you want? All sorts of things. Do you want synthetically generated data? You can go and filter for all this right now easily in a repository and download all the various Hugging Face data sets that abide by your rules. And so Stability AI releases Stability LM that use this for the fine tuning. The IM model has used this. There are some other models, high profile models and data sets that are starting to incorporate this. The second use case is for researchers like ourselves who want to uncover patterns and biases in the data at an ecosystem level. So how are things moving and where are things going? Anthony is going to talk a little bit more about that later. And there's some really interesting trends that were previously not well empirically validated or shown. And the last use, and this one is more future facing, but there needs to be a way for data creators or even websites beyond data creators, not just the individual artists, but to understand where and how their data is being used. That's just transparency with legal implications at the end of it, most likely. But we had people who were really interested to find, oh, wow, like Wikipedia, retweeted us and was like, we didn't know that, X% of our data sets, of data sets highly used in AI Hugging Face community were originally generated using Wikipedia data at some point. Or vice versa. And so we're starting to build out the infrastructure where you can look at the contents of data, you can choose the right data, but you can also look back to maybe where it came from. And we think that it has a lot of implicit use. Jump in, Anthony, when you want to take over. But more or less, this is sort of just a GIF of like the tool and how you can use it and select different knobs and toggles to get what you want, and then go and inspect that data. Next slide. There's a lot of information there about the text data characteristics. You can go download the data. You can look at the licenses. You can look at who created it, what tasks are represented. Next slide. Do you want me to do these couple slides quickly, Anthony?
Yeah, go ahead.
Sure. So one really noticeable example of a pattern that we uncovered by doing this ecosystem audit or analysis is looking at these top 2,000 data sets. We try to compute the representation of language and map that onto the countries that spoke those languages in the globe. So there's a formula in the paper that shows how we did this. And we were able to empirically validate the known skew towards Western-centric and English-speaking cultures in the data that we use. So this is kind of surprising, but how we can measure it, but it's kind of known. But the next slide shows that we're actually able to look at the organizations that contributed to harnessing and creating those data sets and where they were based. And you can see that it's extremely stark. It's way more stark than the language representation, with heavy concentrations in the US, North America, Europe, and China, and little to no representation in the global South. And so if we see these side by side on the next slide, we can kind of see that stark contrast. And next slide, our conclusion from this is that a global minority is driving the creation of data sets that affect all of us. And it exists at the creator scale as well as the language scale, and we have the ability to now measure and look at this.
Do you want to
Sorry, say that again.
Do you want to take these next two as well, and then I can go over the files?
Sure. This is just an example of looking at differences between new synthetic data, where people often use OpenAI or other tools to create that data compared to the conventional, more academic data sets that were being created prior to late 2022. And we see big differences in the distribution of the input and output text lengths, as well as the tasks that are represented, and a whole lot of things. And this is just one example of the types of things we can plot. Where on the right, you can see a lot of the blue dots are sort of the older generation of data sets. And then the other colors are the newer generation, where they have much longer text lengths. That meaning the outputs are much longer. They're more like, write me a story, you know, write a full article, or do complex chain of thought reasoning, which is more modern and very useful for training. You can also look at some pie charts related to.
There's a question here.
Yeah. What do the contours mean?
What does the what mean? Sorry.
Contours, like these lines. I understand the data.
Yeah, the contours are just sort of like showing like a heat map. They're not strictly very scientific, but they're showing the center of where most of those data sets of that type, in this case, the synthetic versus non-synthetic data sets, what spaces they tend to occupy in this XY axis of input and output lengths.
Wait, so like an isolated green X, for example, has at the top center of the right graph has 3 circles around it. But then the like over further to the right, there's a little blue circle that doesn't have any circles. So does that mean something like that the variance is greater on that single data set? Is that the idea?
I think that's happening specifically because there are fewer green data sets than there are thousands of blue original academic data sets. And at this point, there were fewer, in this case, OpenAI GPT-3 generated data sets. And so that just has is giving contours, while the blue ones are more outliers and so aren't.
No. I'm saying that there's a blue dot that has no contours around it at the top right. And there's a green dot at the top center that has 4 contours around it.
Yes. The reason for that, I believe, is because there are many blue dots and very few green dots. And so green dot, even one green dot is getting contours, while the blue ones aren't, just based off of how Seaborn does it. Yeah.
Gotcha.
I'm
sorry, are the crosstabs based on the filter? Like the global representation take those. So if I filter down to a single data set or something, that'll get me, then the global representation will change.
Yes, I need to, you can filter down to different subsets of the data, and then it will automatically generate that heat map, global map for you.
All right, thanks for the questions. Want to keep going, Shayne?
Sure. And I'm happy to talk more about this, or feel free to use the tool and we can like dive in a bit deeper. There's a lot of graphs we haven't gone over, but this is just sort of a breakdown of the data sets that we covered and what the task distribution is, and what's sort of covered there. And I'd say a lot of this has shifted towards more of the small categories in the top left that are more like creative writing, response ranking, common sense reasoning. Those are way more popular now than, you know, simple text classification data sets.
Yep. So I think what we'll do now is say, like, there's a bunch of analysis, but feel free to try it out in the Explorer, and I can keep going.
So can I ask a question that's specific about like a thing I wanted to do?
Sure.
So in this slide is perfect for it. So you see it says Twitter 1.67%. So I was trying to figure out, okay, what data sets have Twitter in them? In particular, Twitter is interesting because you have a lot of people who will put tweets in their data sets, which is totally illegal. Well, totally against Twitter's terms of service, right? But I'm trying to figure out how do I, like, if I got this kind of statistic, how do I like then go back and figure out what data set has Twitter in it?
We can show you that offline,
but not using the Explorer.
Is it possible via the Explorer to filter just by the Twitter, just by these columns, right?
We could add that very quickly, but you can use it in the repository.
But also in general, like, is that kind of distinction between like when somebody, like in particular, this matters for Twitter, I guess, has tweet IDs versus hydrated tweets, is that reflective at all? Like, do you have like illegal as one of your categories?
So there's Shayne, you want to say something? Go ahead.
Illegal as a category, that's a whole can of worms. What is illegal is being decided.
Okay. Against, yeah,
and it depends, yeah.
TOS violator.
But the way that you would see it, it's being filtered up into the categories that we have, right? The academic, the commercial, non-commercial. So that's, but we don't have a legal.
Yeah, there's no, like, null space use, right?
So there's, yeah.
Can I add two things really quickly? It's quite nuanced. There are many stages of rules around data or imposed terms or contract or copyright, and that starts from the original source and it goes all the way to a series of data sets that have been transformed and relicensed and repackaged. Some call it data laundering, others say it's just reuse. And we track the final licenses and terms it was generated by a model. We haven't gone back, but we're now starting to do that to look at the original terms associated with every single website. But that changes over time. And also the enforceability of licenses for some of the final data sets have been, if you paste your own license on top of a Twitter data set or a Wikipedia data set later, did you put enough human input into that to transform and have copyrightable or licensable privileges is like an open question, really specific. And so our goal is to try to add as much metadata as possible to decide that, but really it's a jurisdictional and individual, legal question in every case.
Yeah, I will also add that there's complications around fair use. And so there's no precise definition around fair use. And when you have multiple stages of transformation along the way, what is fair use and what is not so it's hard to just say illegal on a data set.
When it comes to the human versus model generated annotations, are you taking the word of the papers generally for that?
Yes.
And is it a human like scouring of the paper to understand what's been done?
Yeah, so this is where a lot of man hours has gone into, is going to the data set. If there's no license, reading the paper, seeing what generated, maybe there's no data set there, but it was built off of another data set. Okay, then we go look at the data set that led to that. And maybe there was a license there, so then we propagate it all the way back up. So this is where, like, I would say a majority of the time went.
If you have a human and a human corrected first pass machine generated, do you consider it human or machine or both?
I would say that the source there is primarily the machine,
really,
since it's generating. But yeah, Shayne, do you have anything you want to add to that?
Sorry,
the question was around.
Yeah,
so the question was around if you have data that was primarily generated by machine, and then let's say edited a little bit.
Well, no. What I mean is, like, so for example, the Pentry Bank was created by first running, let's say the part of speech tags of a Pentry Bank in 1990. It was created by using a first pass part of speech tagger, like a rule-based part of speech tagger, that then every sentence went through human checking, and they checked every tag theoretically and changed them, but there's bias. And my point is would that source be considered human or a machine or hybrid according to your ontology?
If the labels are used as an input or output for training, then in any of those are created by a machine, then we include that as machine. So something Google translated or something that's synthetically partially generated by OpenAI in the loop, even if humans edit it, we would say has a machine generation. We'd rather show all the sources rather than omit some.
Okay.
That's a good question. So that's the Explore. Thanks, Shayne, for covering that. I'll now go over some of the findings from using the Explore and talk about why some of these things matter, especially today in 2024, since there's been a lot of changes over time. So the first question that we wanted to answer is how accurate is the licenses that are publicly available, Hugging Face, GitHub, etc. And different aggregation sites have different correct different percentages of time. So we talked about this before, but Hugging Face was about 65% wrong of the licenses that were there. Papers with Code is correct slightly more, and GitHub is somewhere in between the two. In addition to correct versus incorrect, there's this huge problem of there's no licenses at all. And that leaves a lot of room on the table for training machine learning models. So before we did this analysis, we found that there were about 69 to 72% of the data sets had no license that we could find at all. After we did the annotation, which includes like going back to the paper, a data set that led to this paper, etc., we were able to cut this down by more than half. So about 30% of the data sets in Data Provenance Initiative didn't have a license associated with it. This cut the error rate down a lot, but there's still a lot more work to do, with that 30%. The thing that's interesting as well is to see what is available by the different license types. So here is a sort of long tail plot of all the different licenses that we found in the Data Provenance Initiative. So some common ones are the common for all in their different incarnations. OpenAI now is a very large chunk. So OpenAI has their own license, and many of the data sets in DPI are OpenAI generated. We also have this large group of custom licenses. So what you see now is, companies, as they create models, create data sets, they have their own specific wants, needs, and criteria in releasing this. So they'll write their own custom license, and we aggregate them all into this one group. But as you can see, there's this long tail. Some of them have no licenses, etc. And so what we see is that most of the data sets that we looked at were commercially permissive, meaning that you could use them to train a machine learning model and use that in a commercial way. But the thing is that data sets are getting better over time. These days we don't just want reading comprehension data sets or sentiment classification data sets. We want open-ended generation. So it's worth looking at how restrictive or permissive data sets have gotten over time. And the main thing that I want to point to is this 2023 graph. So this red is non-commercial academic only. And for most of the time, it's been pretty, I would say, consistent. But in 2023, after ChatGPT came out, after people really saw how useful LLMs were, this jumped way up. So I think you can see that people that are creating data sets, especially if they're from a company, they know the worth of the data. And so a lot of them are making, it's becoming aligned with the licenses that are in the data sets, I would say.
Do you know, sorry, these data sets, the license came in, is it when they uploaded?
When the data set was created.
This is from the papers, basically.
This is from the papers, yeah.
So they're definitely saying NC academic only.
Yeah. And I will also say that a good chunk of this red could be like the OpenAI synthetically generated text as well. So I think more people are using OpenAI to generate text, and that would fill into this red group here.
Have you plotted this on a course of whether or not the license was created by a commercial versus non-commercial entity?
I don't think we did that, but that's a good analysis.
It'd be interesting to see if commercial entities are largely making their things NC academic only.
Right. Let's see. It's also worth looking at how commercial or non-commercial these data sets are by the languages that are in DPI. So there is, so on the top here also are the 22.9. These are how many of the data sets are in these groups. And so you can see in the Indo-European group, which includes English, there are many more data sets that are included that we looked at in DPI. As we look at lower resources language like Korean, this is represented far less. But you also notice that different language groups have different ratio of commercially usable versus non-commercially usable. And the thing that's interesting is that for English, a lot of the data is unspecified, so it's not clear. So yeah, I think people that create English data sets, I guess, need to do a better job of putting a license on the data set. The other thing that's interesting is based on the domain or task type, what are the different licenses that are associated with them? So maybe I'll point at, let's say, data from the biomedical domain has much more non-commercially usable versus academic. versus governments where it's largely unspecified. Shayne, do you have anything interesting to add to this slide?
No, I just think this is packed with information that often like gets lost, but it's really interesting to see where information comes from and how that affects its availability for different applications. So if you're building something in the biomedical domain or education, there's going to be less open, publicly available, and permissively available data for you to use, and that can cause differences in what the open community can do versus what startups or companies can do.
Wait. Go ahead.
I was just gonna say, let's say for like the exams or some other, let's say for legal, there's a lot that's unspecified, like 50%. What's the action that you can take there? Let's say an academic, what's the recommended action? Should you use this or should you stay away from it just to be safe? Or
As our lawyers,
This is the legal advice.
okay.
So
Shayne, do you have anything to say there?
I'll just say I've heard many different things from different people. Lawyers are intentionally conservative, and I'm not a lawyer, but I've heard some say that even if you're a company doing research, you should avoid certain data sets. There are data sets that are working at Google or other places, I won't name them, but you cannot download them. They don't want them on the server, even though many academics use them on a regular basis. But if you're a university academic, there are many data sets here that maybe should have research done on them, and it's okay. But that's starting to be called into question, and yeah, I think it's very nebulous. I mean, we released the Flan collection, which had many non-commercial data sets, but like it was intended also for people to use in academia and for research. And if someone uses it commercially, that's on them to do their due diligence. So I think there are great questions here, but we need lawyers and AI people working together to answer them.
So you had a graph before that showed the different licenses themselves, and there were only 2 data sets that had no license, right? There is this one that says request form. Oh, that's where you have to request. That means you have to request the data. That's the idea. Okay, so or various, I guess, in custom. But like, if a pretty significant percentage of data sets then it's not clear whether they are commercial use allowed or not. That means there's certain large categories in here, right, that are actually no. So these are all coded as blue or red. I guess the purple might not be clear about whether it's commercial use allowed. Is that the idea?
Shayne, do you want to weigh in here?
Sorry, I'm only hearing parts of the question, but blue is commercially viable, red is non-commercial or academic only, and then the purple stuff has to do with the attribution or share alike. We tried to fit a lot of info in this graph. No license means that they specifically said there's no license on this data set. That's different from no license actually appearing, because you might still have copy, presumably according to American law, as soon as you create something and put it out there, you still have copyright permissions over it, even if you don't say put a license on it. So saying there's no license versus not saying anything is different. Yeah.
Does that explain the difference?
No, but it's okay. It can't. I'm trying to understand why there's such a huge chunk where you don't know whether it's commercial or academic, but it doesn't look like there's a huge chunk.
Because in the no license, they're specifically saying there is no license.
And that's just 2 cents.
Right, but
the purple is if you look at the legend in the top right, the purple has to do with share alike or attribution, which goes on top of.
No, I think
I'm trying to square that with all this green.
The yellow,
so we didn't include the unspecified here. Yeah.
Yeah, so no license means that in the paper they said there is no license. But if they don't say anything about a license, that's not included here. Yeah. All right, this one is really interesting as well. I think this one correlates with the data sets over time becoming more restrictive. So here we looked at, based on the tasks in the data set, what percentage are commercial versus unspecified versus non-commercial. And we can, if we sort them by restrictive or permissive to restrictive, we can see that this sort of correlates to the tasks that the NLP field was interested in over time. So back then, we were more interested in short task generation, text classification, and these are either unspecified or commercially usable. But as we get to the tasks that LLMs are, that we expect LLMs to be good at and that we might turn to them for, like chain of thought reasoning, explanation, creativity, brainstorming. These are increasingly restrictive. And so, yeah, going back to the task domains, this sort of restricts what a commercially usable LLM could be good at down the line. So that covers the analysis that we did. I think it's worth covering what comes next since this is an ongoing project, and I'll throw it back to Shayne here to wrap up.
Thanks, Anthony. I'll go through this really quickly, but first off, fantastic questions. There's a lot of nuance and complexity here, and thank you for diving so deep on asking this. We can go into more depth in a second too, but can you just go forward a couple of times, Anthony, so I can show the dots? We released the first paper, and we're working together with actually around 40 to 50 contributors in a very decentralized, organic fashion. Anybody that wants to contribute is willing to add data sets or features to the tool or help us annotate now pre-training data sets, vision or speech data sets, is helping us do a much wider ecosystem audit and dive deeper into the sources of data and the terms that someone asked about earlier. So we're planning to write a new big paper and have a new big launch later this year. And we got some good press from the first one, meaning that I think people really care about this. And so we're planning to double down and try to build tools that people can actively use in a very open way to help choose the data in a more responsible and informed way.
Yeah, and I think there's
slide.
a bunch of, just to touch on this, I think there's a bunch of interesting questions here. So questions around, let's say, training. If you're restricted to just say very permissive licenses, how good, what's the diff between training on just that data versus training on that data plus commercial, commercial versus non-commercial subsets of the data? I think there's lots of interesting questions that haven't been explored yet that we're trying to cover in the next version and moving forward. So this is the website. We have a Discord channel that we all communicate on. We have regular meetings every Wednesday where people that want to contribute to this project can join and get caught up to speed. And everything that we upload is on a centralized GitHub repository. So it all stays together and it's pretty clean. So you can go there and make pull requests and upload your own data and do interesting experiments. Yeah, thanks for having us.
Awesome. Thank you so much, Anthony and Shayne. Let's first give some time for questions if we have any from the audience. I know we asked a bunch throughout the talk, but yes.
Yeah.
So you talked mostly about data. I'm interested about model issues too. I think one kind of use case that came to mind was, I believe, don't hold me to this, but I believe I was looking into Falcon, which I believe was released as Apache 2. But then if you look at the data sets that it's trained on, some of them were Apache 2 and then some of them were not Apache 2.
Yeah.
And a question I guess that arose is, okay, does that poison the well? And then of course is this, like the paper for Falcon says we release it under Apache 2.
Right.
So actually wait, I don't think Falcon had it even at that point. Maybe they do now, I don't know. But like it was like uploaded and they wrote it there. So the approach that you're using right now, I guess, if you extended that to models, well, I guess I don't know what happens in this kind of case.
Maybe I'll respond and then I'll pass it to Shayne after. So we see this issue with data as well. Let's say someone takes a data set that already had a license that you had to use, and if you created, follow-up versions of this data set, right? And then they take this data set, they throw away the original license and slap on their new license. Part of what we want to do in this initiative is go back through the chain of how this data was created and find out licenses that were lost along the way. So if you just think of these models as another point in this chain, I think the same process applies. Shayne, anything you want to add to that?
Yeah, I don't think there's a solid answer right now that I've heard about what happens. What is the license for a model when it was generated by certain data, and how do those apply? People are picking and choosing what things they want to pay attention to in the prior data that went into a model or prior data that went into a data. Some of it might be covered by fair use, some of it won't. even if it is covered by fair use, it might not protect the artists or creators in the first place, or give them compensation or consent. That's unsolved no matter how the law sort of pans out. So yeah, I'd say these open problems. There's also a couple questions in the chat, by the way, Anthony, depending on what order you want to go in.
Oh, sorry, I missed that. Let me direct this. So the first question is, what are best practices for papers creating data sets that would have made your job way easier when you were annotating and just documenting the data set and its license?
Shayne, you want to take this one?
Yeah, just documenting with a couple sentences in the README or the Hugging Face data card or the GitHub README or wherever you host your data, what the data license is. So many people will create a GitHub repo, do the dropdown in GitHub and say, okay, MIT license, and not give a second thought. And then we're like, does that a license apply to the code, to the model, to the data? None of the above. And if they don't specify, our advice is we should say unspecified, because it's not enough to necessarily cover all those things. And so just being clear and having a sentence somewhere would make it infinitely easier. And eventually we'd like for people to treat Hugging Face more like Wikipedia or some repository like that, where they can actually go in and people can correct licenses and people can say, no, this is the accurate license based off of what the authors intended. Here are the sources of the data. So people can say, oh, well, it was created from New York Times and Reddit and Twitter data. And then maybe someone can have a repository that pulls those terms of use. And, there can be like an automated way of distilling all the intentions and concerns in one place. That would be the dream. Right now, it's the Wild West. And whether or not that matters will depend on, the legal system and what it says.
Great. Another question by Maxine is, were you able to detect any instances where a synthetic data set was published under a license incompatible with that of its sources? So for example, the original data set is, I don't know if I'm reading this correctly, CC by SA, and the generated data set is CC by TCP.
Hundreds of examples. That's the short answer. Yeah.
Yeah, there are a ton of data sets these days that are created by mining GPT outputs, and yeah, lots of them have other license stuck to them.
What are the consequences for doing that? Right now, there's none.
There's none.
Yeah, I mean, so in like biomedical realm, I think they treat data, I hope they treat data totally differently from the way we treat data, right? I mean, you basically can get your hands on it.
I think we should go back to the by domain.
And, everything is put through, at least in the academic sphere, put through IRB permissions, and there's, fairly strict training on this. And I wonder if we're going to move toward that and if that'll have a slowing effect. It certainly does in medical sphere.
Yeah, I think it's interesting looking at the percentage of the data, the domains based on how many are unspecified. And if we look here, far more of the biomedical compared to, let's say, governments are specified one way versus the other.
I meant biomedical data, like
oh, I see.
Test results.
Yes, 100%.
Super difficult to share stuff, right? Which is like under lock and key.
Yeah.
Very strict protocols for collection and for dissemination. Yeah. But huge amounts of data are collected.
Yeah.
I'll add one thing. The NIH, I believe, it used to be that medical data sets, like, I don't know, causal analyses of certain treatments or something, people would write a big paper. This I've been told by biomedical folks interested in this, and that then they would never release their underlying data. But now, associated with many of the grants the NIH puts out, they require people to release that data, and they're starting to be put into repositories. But there are so many privacy and related concerns that it's a big challenge for those repositories to create discoverability, create access controls that work, that are more multifaceted than what's on Hugging Face. But they're trying to do it because they recognize that sharing data from many different places with researchers in a responsible way could unlock new tools and abilities, and especially like DNA data and protein data. There's obviously a really big desire to aggregate that in a responsible way.
A very small detailed question. You're showing it here for a bit, but the code distribution for the code domain. there's one here where the code percentage is, it seems like there's a lot of unspecifieds and a lot of non-academic only ones. But then I think a few slides before, when you were talking about languages, just
Yeah, much more commercial.
much more commercial, and I'm wondering how these two are compatible with one another.
Yeah, I forget. This was like some very weird, they're not the same slice exactly. One is like, what's the source? I think the way we plotted this was like, if the data set contains some code, whereas the other one is like, it's exclusively from code. I'd have to review, but there's some like nuanced thing like that. But I can check that.
Yeah, because I was surprised that so much of this was commercial, but then, and I think the other one actually was more up to my understanding of what data sets would probably look like. But anyways, yeah.
Yeah, if I remember correctly, so both of these graphs were model generated. So I think we used prompting to create these categories. And so maybe the prompt that we used for these two might have been different when doing the filtering. Like Shayne said, one might be exclusively code versus the language one might just be doesn't have any amount of code within it.
Gotcha.
Yeah.
Cool.
Right.
Yeah, I think that's all for questions. So I think we can wrap up here. We're almost at time anyway. So let's thank Anthony and Shayne once again.